Hello, my name is Abdullahi Ahmed, and I will be presenting today Building Performance Diagnostic and Evaluation in Low Energy Retrofit. I'm from Coventry University Institute of Clean Growth and Future Mobility. Low energy retrofit and building performance diagnostic associated with it will be quite essential in ensuring that we achieve the socio-economic and environmental benefit of building performance improvement. Built environment account for a large proportion of energy and carbon emission, and with a lot of our buildings constructed before the current energy efficiency standards, the building performance retrofit is going to be essential for achieving net zero targets in the near future. A lot of the existing buildings are coming to the end of their useful life, and we have to improve them, and without the significant cost and environmental impact associated with new construction. There are some challenges that we have to be aware of: the performance gap, the unintended consequences of building energy efficiency improvement, which is therefore essential to look at low energy retrofit in an using integrated approach, bringing together technology, process, and users, as well as having a systematic process of pre and post intervention performance evaluation. Within the confines of this project, we have a range of technologies to select from envelope technologies to building services systems, lighting technologies, and renewable energy systems. I'm not going to go into too much detail because the focus is on the building performance evaluation. And we have a number of components to the building performance evaluation: building fabric, Uvalue testing, thermographic survey, structural and asbestos survey, and environmental quality evaluation using objective and subjective evaluation methods, as well as system performance monitoring and building performance modeling. We also utilize a lot of the existing data from our utility metering system for energy benchmarking, and which leads to the selection of case study buildings. We implemented a stakeholder engagement process at different stages of the project lifecycle. User perception before retrofit that led to the selection of certain technologies for some particular location, especially the use of the phase change materials to reduce temperature fluctuation in spaces. User acceptance of the selection process. When we selected the technologies, we got the views of users and stakeholders, user acceptance in the installation process, the level of disruption, office closures, noise, and also user perception of the retrofit process after the end of the intervention. We did some energy benchmarking, which initially helped us to narrow down the buildings that we were considering, even though this building have the worst gas performance, but because after our stakeholder engagement with the building owners, Coventry University, it was not possible at the time to retrofit this building, so we had to go for alternative buildings. We selected two buildings, John Lang Building and Richard Crossman Building, in Coventry University. These are a mix of offices and lecture rooms. And in Richard Crossman Building, we had a whole building retrofit, changing all the windows from single glaze metal frame windows to double glaze windows, a whole roof installation, the installation of building energy management system, and a new mechanical ventilation system as well. In John Lang Building, we had some localized interventions, such as phase change materials in selected offices and also in selected student working spaces, a ventilated facade, some panels on the surface of the building, a vacuum insulated panel, as well as aerogel super insulating mortar. And these are targeted, localized locations so that we can test the U-value improvement as a result of this. And we use two methods of U-value measurements: the surface heat flux measurement, as well as the non-contact method, which uses thermopile technology. Thermopile is essentially an infrared sensor. It produces a signal that depends on all infrared light it receives, and it's much easier it's much easier than the heat flux measurement, because you don't need too much connection. You just need to have one sensor on the wall with direct view of the other wall. That was logistically much easier for building retrofit. And the difference between the two methods was about 10%. So we believe that this is quite accurate method. The U-value measurement results from the vacuum insulated panel, we achieved more than 50% energy U-value reduction, and over 60%. And in the case of the aerogel mortar, about 60% as well, reduction in U-value, which is quite impressive. So after the initial user evaluation survey, we identified spaces that have high overheating complaints, and also rooms that have high temperature fluctuation complaints. And we injected some thermal mass into those spaces using PCM tubes in the roof of the building, as you can see here. And we use IoT-enabled wireless sensor equipment to monitor the internal environmental conditions and the external environmental condition, and have a dashboard to monitor the data coming through. We also evaluated objective information, and we found that the PCM objectively reduces the peak temperatures in the spaces compared to spaces without PCM, the control rooms. And also, when we did our indoor environmental quality evaluation, user acceptance evaluation, we found that there has been significant improvement in those spaces that we evaluated. As you can see here, we have reduction in people that choose 1 and 2 and even 3, and we have significant increase in people that choose 4, 5, and 6 post retrofit. And the energy consumption in terms of the overall results of the two buildings, the Richard Crossman building achieved about 49% reduction in total energy consumption, a kilowatt hour per meter squared, and in John Lang building we achieved a change of about 11% compared to pre-retrofit. But as I mentioned before, this is more targeted intervention in small areas. It's not over the whole building. And the biggest thermal breach in that building is the windows, metal frame windows, single glaze windows, which was part of the initial plan for the retrofit. But during the asbestos survey, we identified asbestos packers around the window, and it was therefore almost impossible during the timeline of the project, of the research project, to be able to do some of the control removals and so on. And also the buildings are occupied. It's very difficult to manage that. So we effectively did not change the windows as initially planned. So we achieved a reduction of about 11% in that process. The stakeholder engagement throughout the process was carried out, and the key finding was the stakeholder engagement must be early, deliberate, as well as for a specific purpose. Must be planned throughout the project life cycle. Engage wider stakeholders in the technology selection process is really essential. And we developed a framework of performance diagnostic, which looked at the various components of the building performance diagnostic and evaluation, from building occupants, intervention at various stages, before retrofit, during retrofit, handover, and during use, as well as the user data collection, decision-making metrics, performance metrics, building simulation, pre-retrofit BIM modeling, and building monitoring pre-retrofit, and also building monitoring post-retrofit. Thank you. I have more details of this presentation in this paper, so if you're interested, feel free to check it out. Thank you.